Okay. All right, so section 1.8, so for you guys at home, this is the next section. Your quiz open today, it'll be due Wednesday. I may actually change that to Thursday by the time I get done with class today. This assignment won't be due till Friday, if we get most of it done. So 1.8 inverse functions. All right, those are the bullet points. So first thing we're going to look at, what is the definition of inverse functions? How do we look at inverses graphically, numerically, analytically? Given a function, how do we find its inverses? Its inverse. Proving two functions are inverses. And the last thing I need to add is this is one-to-one functions. All right, so 1-1 is one-to-one functions. So we'll talk about that. All right. Easiest thing to do is just dive right into it. So we're going to look at x cubed. Is that one of our basic graphs, x cubed? Yeah, so we'll look at that one. And at the same time, we're going to look at the graph of cube root of x, and I'm going to put them both on the same axis. So I'll graph f of x there in black, and then I'll graph cube root of x in pink here. We can kind of put both graphs on at the same time, and hopefully we can see that there's a relationship. Okay. So yeah, I graph them on your calculator. That's good. So when I look at both of these graphs, what do you notice? What do you see? I graph both of them simultaneously. Anybody sees anything like in terms of symmetry? Not the origin, but close. You got the right idea though. Instead of the origin, look at the line that runs through the origin. What's the most basic line that runs through the origin? Yeah, y equals x. So they're symmetric about y equal to x. Their mirror image is about that line. So if I flip the pink graph, see, look, just look at this part. If I flip it there, it lands on the black graph. If I flip the black graph, it lands on the pink graph. So it's symmetric about y equal to x. Okay. The other thing is so that's what we see there. So graphically, what do we notice? That they have symmetry about y equals to x. So we're going to put like a little bullet point there. That's for graphically. So for graphically, so G, symmetry about the line y equals to x. Okay. So if you graph a function and its inverse, you kind of have to tilt your head a little bit and look, but that's what you should see. Now let's look and see what happens numerically. Numerically means let's look at points, okay? Specifically, let's look at points. So on this graph, this is not the best picture here, but do you agree that f of x has the point 2,8? Do you agree with that? Okay. When I flip this point about the line y equal to x, and now the problem is my picture is not to scale, so that's the only thing that's confusing about it. So this picture is not to scale, but we can maybe at least think about what we think here, what we think is going to happen. If this is the point 2,8 on F, what do you think is the mirror point over here on G? 8,2. Yeah, is 8,2 a point? Let's see. Well, if I plug in 8, cube root of 8 is 2. Yep. And it will always work like that, no matter, bless you, no matter what point you pick. So for instance, I'll just extend each one. All right. What point is here? If it's at 3, what's the y value there? Cube it. 27. Right? Then if I flip, what do you think is the mirror point there? So what do you notice that's happening numerically from one to the other? What's happening to the x and y's? There's flip. It always happens. Now, right here, notice this is where the two graphs intersect, because they're intersecting because that's where they are on the line y equals to x. So what do you think is the point right here that they both share? 1, 1. That's exactly right. So 1, 1, if you flip 1, 1, you still get 1, 1. Right here, what's the point that they both share? 0, 0. But it also works for negative. So if this is the point -2, -8, then the flip point is -8, -2. All right. So let's do this a little differently. Let's look at it numerically here. So now numerically, if AB is a point on a function, we'll just say on f of x, then blank is the mirror point on the inverse. So I've left it blank. If AB is a point on a function, then what's the mirror point? BA. There's your numerical. Okay. So G stands for what's going on graphically. They have symmetry about y equals to x. N stands for what's happening numerically. If one has the point AB, the other one has the point BA. And then we'll look at what analytically means in just a second. Okay. All right, so I'm going to erase this. It's taking up a lot of space. Let's look at our 2 again. So we knew that we had x cubed and that we have cube root of x. Those guys are inverses. So I'm going to start with x cubed, and I want to show you how another way that I can show that they link up, that they're connected. So if we take this point here, basically the x's and the y's are doing what? Flipping. So as we go from one to the other, the x's and the y's switch. Well, that's actually how you find the inverse. So let's say I didn't know what it was. Let's just say we didn't know the inverse of cube root of x. We don't know what it is. But I can show you now, if you use that thinking, how you can find it. So if you want to find the inverse, so to find the inverse, switch all x's and y's and solve for y. So wherever I see a y, I'll put an x. Wherever I see an x, I put a y. So there I go. I switch all the x's and y's because that's what's happening, okay? So wherever I see a y, I put an x. Wherever I see an x, I put a y. But then I'm going to solve for y. Well, how do you solve for y if it's y cubed? Cube root. So you take the cube root of the left, and you take the cube root of the right, and the cube root of a cube is just that, and you have found it. And now we see that there's a function, this is its inverse. Okay. So to find a function, or to find the inverse, you switch all x's and y's and solve for y. Now, there's a symbol for this. Instead of saying that y equals cube root of x is the inverse of f of x, right? Mathematicians are lazy. Nobody's going to write all that out. So what is another way I can say that this is the inverse of f? Well, we have a symbol. So the symbol for this is, we just use f, we put like a -1 up here, and then we put x. So we say f inverse of x. This doesn't mean 1 over f, it just means that this is the inverse. So I'll write this f inverse of x is cube root of x, and that means that it's the inverse of f. Okay. So I'm going to give you a function. I want you to find its inverse. Okay, do you understand the procedure? All right, good. So we'll call this example 1. Given f of x is 5x minus 2, find f inverse of x. Okay. Go ahead. So I would take f out and call that y. So what are your steps? What's the first step? What do you do first? So it's all x's and y's, and what's second? Solve for y. There you go. Okay, so let's look at our steps. So we just say y equals 5x minus 2. Then we're going to write x equals 5y minus 2. But we don't want to write our functions x equals. We usually write our functions how? Y equals. So we're going to solve for y. So what would you do first? Add the 2. We get x plus 2 is 5y. Then what? Divide by 5. So we get y equals, you should have got x plus 2 over 5, and you could then call that, you could make it f inverse of x. Okay? How's a way I could kind of check to see if this was right? What's something I could do? Like I say, okay, I did it and I got that answer, but how do I know for sure that those are inverses? That's a good idea. So what Molly said is, she said plug in a coordinate and see if it's switched. So let's say if I do like on this graph, I just plug in a 1. If I plug in a 1, we get 3, all right? Well, that means that this graph over here should have what point?
3.
Well, let's see. If I plug in a 3, 3 plus 2 is 5, 5 over 5 is 1. So do we feel good about that? It's a quick check, okay? All right, and you know in my math lab how they may have some graphs, they may have you move some points and things like that just to show that, all right? Now, so that's pretty easy because that's a linear function. We did a cube root there. What about, we'll call this one example 2. If I say f of x is x squared, let's find the inverse of this. All right, go ahead. Be ready to share your answer and then your reasoning for your answer. Done already? You got it? All right, it's like 2 steps, right? Okay, so let's see. First, I would call it y as x squared, then we will write it how? X equals y squared, then what did you do? All right, square root of both sides. What did you write for the answer? Y equals the square root of x, and you call that f inverse, okay? So, anybody else, anybody get anything different? Did everybody get the square root of x?
Would be plus or minus the square root of x.
Okay, so we got this answer, and we also got plus or minus the square root of x. So one group got the square root of x, another group got plus or minus the square root of x. Why did you put plus or minus?
Because if the inverse and you're doing the whole function, put plus or minus get both sides of the x.
Yeah, so let's look at this. By the way, both of these answers are going to be wrong because I've contradicted the lesson, but I'm doing this on purpose so I can teach you why they're wrong. So let's look at this. Technically, by this question, this is right, but it's wrong because of the title. See if it clicks in a second. Let's draw it. Here's y equals x squared, right? So if we just want the inverse relation, then this is right. This is not enough. So if you look at the graph, if we put in pink again, the inverse, this is all that, if you give this, that's not enough because you don't have a flip for the points over here. Because look, on the black graph, this has the point negative 2, 4, right here. Well, then if you want the mirror should be here at what? Where should the mirror be? 4, negative 2. Well, you don't have that. What you do if you do this, right? If you do this, if you do or if you do f inverse of x is plus or minus the square root of x. So if I do a 4, f inverse of 4, I get plus or minus the square root of 4. So I should get plus or minus 2. So I should get the negative 2 answer and the positive 2. The only problem with that is I got two outputs. So if you do draw this entire graph, like Spencer said, put that point to there, that's what the inverse should look like. But the pink graph is not an inverse function, it's an inverse relation. The problem is our title is to study only inverse functions. So it's not really this guy's fault, is it? Because the pink graph came from which graph? Where did this guy come from? Came from over here. Now, this fails the vertical line test. But it fails the vertical line test because the black graph fails what we call the horizontal line test. See, it fails this test. If I can draw a horizontal line and it crosses more than once, then when I flip, I'm not going to have a function because it's going to flip vertically like this. Okay, because if you think about that symmetry about y equal to x. So the whole problem starts here. This technically is the answer. It is plus or minus square root of x, but this is not a function. And our topic is to just find inverse functions. Okay? So the question is, well then, how are we going to work this, or what's going to happen? Well, in order for a function to have an inverse, it has to be what we call a one-to-one function. So for a function to have an inverse function, so for a function to have an inverse function I'm going to underline, the original function must be one-to-one. And what does one-to-one mean? For every x, 1y, and for every y, 1x. So one-to-one means for every x, 1y, and for every y, 1x. Okay? Erase a little bit over here. Okay. So, and we will say must pass the horizontal line test. All right. Okay. So I can still ask you to find the inverse of this. I just can't give you the entire picture. So I'm going to show you how this problem will be phrased, so you're still working with x squared and you still get an inverse function. Okay. So let's look at example 3 and see how it's adjusted. Okay. There's example 3. F of x is x squared, x is greater than or equal to 0. So the first question I have on this is f of x 1 to 1. If so, find the inverse function. So notice now what has happened that's different on this question. What did I do, Andrew?
You said domain further.
Yeah, we restrict the domain. So we're restricting the domain to only x greater than or equal to 0. When have you seen that before on a function where the domain was restricted?
The square root, you can't go into like a negative.
Yeah, but when have you seen like x greater than or equal to 0, x less than 0, x greater than 1, x less than or equal to 1? What's that? Piecewise functions. Piecewise. Where I gave you a piece of one and a piece of another. This is basically piecewise. It's just saying, give us this piece of x squared. This is like piecewise. I'm giving you half of a parabola. So now let's look at the picture. Okay. So let's look at this. This is saying x squared, but only for x greater than or equal to 0. So if I look at this, this is not right because this is too much. So I'm going to erase the part I don't need. Does that picture match up to that algebraic equation? X squared for x greater than or equal to 0. Yes. Next question. Is it 1 to 1? That means if I draw a horizontal line, will a horizontal line ever cross more than once? No. So it's 1 to 1, which means its inverse should be a function. So if you have something that's 1 to 1, so for a function to have an inverse function, the original function must be 1 to 1. So since this is 1 to 1, the inverse should be 1 to 1. So now you go through the same steps, but remember, switch all your x's and y's, and this will tell you whether or not you do plus or minus the square root of x. You can't do both of them. You can't do plus the square root of x and minus the square root of x because that won't match up with this. So think about which one you got to keep. Okay? And then that's it. So is f of x 1 to 1? Yes. Okay. Then find the inverse. All right. So you just take this 2 seconds. X is y squared, but y is greater than or equal to 0. So I'm going to switch that to a y. Now when I go to do square root, I'm not going to do plus or minus because it tells me make sure that y is greater than or equal to 0. So since y is square root of x, I'm going to leave it positive because I don't want a negative answer, and that should be my inverse. And now when I go to graph it, I get this picture. Now do those two look like inverses? Yeah. So if that was a question, you would have been right. Correct? Yours was technically right, but it didn't match into what we're studying. But according to the question I had asked the first time, you were right. Okay. All right. So I'm going to draw a graph real quick. You're going to say if it's 1 to 1 or not, just so you know, just so you get an idea of 1 to 1. All right, ready? 1 to 1.
Yes.
1 to 1.
Yes.
No, because it fails the horizontal line test. No. Okay. A piece, right? A piece, is that 1 to 1?
Yes.
Okay, you got it. Easy, right? Everybody good? All right, so do we have the definition of inverse functions? Yeah, it was that basically, you know, if AB is a point on one, BA is on the other one, we kind of defined it this way. given a function, how do we find its inverse? How do we do that? Switch x and y, solve for y. We got one-to-one functions now. The last thing real quick is how do you prove two functions are inverses? That's a O there. How do you prove? So I'm gonna show this real quick. This is the last thing to do. How do we prove two functions are inverses? Okay, so let's start with the first two we had today. F of x was x cubed, f inverse was cube root of x, or g, doesn't matter. I'm gonna call it g. We're gonna pretend we don't know. Okay, here's what always happens. Notice why you wanted to learn composition in the last section, because we're gonna use composition here. F of x and g of x are inverses if this happens. If f of g of x equals x, or g of f of x equals x. If you sub one into the other and you get x, they're inverses. And it has to do with the switching to x and y, thinking about if one graph has the point AB, the other one has the point BA. It has to do with that. So basically, it doesn't matter whether you put g into f or f into g, you should get x. And then I'm going to do we'll test this one. So we'll do this. And then the other one we'll do, what was it? Was it 5x minus 2? And then what did we get? X plus 2 over 5? Check that. So you're going to do either one, and it's basically just showing your work, and you should get x at the end. Okay? All right, so we can do this one here. So if I just do f of g, I'm going to do f of cube root of x. So what I'm going to do, I'm going to take cube root of x and sub it in here. So I get cube root of x cubed. Well, what happens when you cube a cube root? They cancel and you get x. Once that happens, I don't have to do the other way, but you could. If I sub that in, you're going to get the cube root of a cube, but you're going to get x. So that proves that they're inverses. Okay? So why don't you do this one here, do f of g, show your work, and you should get x. What happens if you don't get x? Or you made a mistake. So it's one or the other. So just go back and double check. Okay. It does not matter which one you sub into the other. Sub one into the other, simplify, you should get x. And this is the connection of the last section. Question? Oh no, good. All right, so I just did this. I'm going to put g into f in place of x, right? So I did that. What would be my first? So I went ahead and subbed in. What would you do first? I can barely hear you, but I think I know what you said. Can you say it one more time? Yeah, well, if you distribute the 5, what's going to happen to these two 5s? Yeah, they cancel. Here you're left with x plus 2 minus 2. Well, what do you get there? X. Boom, they're inverses. So there's a difference. Given a function, find its inverse. Well, you switch x and y and you solve. Given two functions, how do you know if they're inverses? Put one into the other, it should simplify to x. That should get you through the meat of the work. When I see you again on Thursday, I'll look through, I may add a little to this lesson. This lesson won't be due until Friday, so I'll add a little bit to it, okay? But this should get you through the majority of the lesson. Bless you. I'll stop there.